Let's talk about chain isomerism. It is a type of structural isomerism. In fact, the first type of structural isomerism that you should look for is the chain isomerism. And when do we observe it? When structural isomers have different parent chain lengths. So the length of the parent chain should be different. And let's see what we mean by that with a few examples. So what we have is two compounds CH3, CH2, CH2, CH3 and CH3, CH, CH3, CH3. Both of these are alkanes. Let's first verify that their molecular formula is same. That is the first thing that you should check. So if you count the carbon atoms in the first compound, you will get 4 carbon atoms and you have 3 to 5 and 2 7 and 3 10 hydrogen atoms. So the molecular formula for the first compound is C4H10. And if you do the same for the second compound, you will get 1 2 3 4 carbon atoms and 3 3 6 3 9 and 1 10 hydrogen atoms. So the first thing that we have checked is that the molecular formulas are same for the two compounds. Now you can clearly see that the connections are different, so therefore these two are structural isomers. Now let's see what makes them chain isomers. Look at all these carbon atoms. They are in a straight chain. So we have a chain length of 4 carbon atoms. Now in this second compound, if you try to find the chain length, you can say that you can go either straight to have a chain length of 3, or you can take this curved path and still have a chain length of 3. So the length of the parent chain in the two compounds is different and therefore they are chain isomers. That's how you decide whether two isomers are chain isomers or not. A very good way to verify whether two isomers are chain isomers or not is to write the IUPAC name. What you do is you first write the IUPAC name for both the compounds that you want to check for chain isomerism. For example, if we look back, we have this first compound CH3, CH2, CH2, CH3, and if I write the IUPAC name for this compound, you can say that this is butane, and then the second compound that we have is CH3, CH, CH3, CH3, and the IUPAC name for this compound is 2-methyl propane. If you have troubles writing IUPAC names, please check my series on IUPAC nomenclature by clicking this video right here. After you write the names, what you do is look at the last part for each name. For example, in butane there is only one word, that is butane, and in the second compound the last word contains propane. If these two are different, then you have chain isomers, because this part tells us the name of the parent chain. So if parent chains are different, they are going to have different names. So if these two are different, you will have chain isomers, and if they are same, they are not chain isomers. Let's take some more examples. We have CH3, CH2, CH, CH3, CH2, CH3. So this compound contains 6 carbon atoms and 3 to 5, 1, 6, 3, 9 to 11, 14 hydrogen atoms. So this is one of the isomers of hexane. If I take another compound with the same molecular formula but a different structure like CH3, CH, CH3, CH2, CH2, CH3. Now to decide whether they are chain isomers or not, look at their parent chains. So the parent chain for this compound has a length of 5 carbon atoms. Similarly, the parent chain for the second compound also has a length of 5 carbon atoms. We can also verify this by writing their IUPAC names. The first compound is 3-methyl pentane and the second compound is 2-methyl pentane. So as you can see, the last part of both the names has pentane, which is not different. Therefore, these two compounds are not chain isomers. You can just look at the name and predict whether they are chain isomers or not. Let's wind up by taking one more example. We can have CH3, CH2, 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 CH3, and the other compound can be CH3, CH, CH3, CH2, CH3. So in these two compounds, both have 5 carbon atoms and both have 12 hydrogen atoms. So if I check the length of the parent chain for the first compound, it has a chain length of 5, whereas the second compound has a chain length of 4. Since the chain length is different, they are chain isomers. You can also verify this by writing their names. I leave that task to you. In the next video, I am going to talk about position isomers. If you look at the previous example, these two compounds were not chain isomers, but they are also not same. So what kind of isomers are they? They are position isomers. How? We will take a look at this in the next video. See you there.